All right, so we'll start by covering some basic concepts about Docker. Just jumping right in here. What is a Docker? So Docker is a platform for building, running, and sharing applications. Docker runs containers, which are portable packages that include software and all dependencies for the software to run. In other words, Docker allows you to wrap up your application and its dependencies together, which can then be shared and run in multiple environments, different types of environments, right? So why is that useful? Code often breaks when it's run in different computing environments. If you've ever tried to run something on your machine that was developed in a different environment, you've likely run into this issue. Or similarly, if you've developed something on your machine and then tried to hand it off to a colleague to run on their machine, they may see problems as well, right? So different software and dependency versions can break code, cause it to run differently, different environment variables, all these types of things come into play when you're running software. Docker addresses the issue of different environments by wrapping the application and its dependencies and shipping them together. So this allows the same compute environment to be used across multiple users and systems. If you're familiar with virtualization, it's worth noting that containerization is distinct from virtualization in that it runs on the host kernel rather than adding an additional layer as virtualization does. We also wanted to point out on this slide that Docker is just one container type. There are other container types, other alternatives, and there's some links here that you can check out if you're interested in alternatives for whatever reason. But today we're going to focus on Docker since that's what is supported by Terra, and it's also arguably the most popular, if not one of the most popular options for containers. Cool. So how does this process work? We're going to walk through it briefly. On this slide, we're showing that an image is created from a Dockerfile and any necessary applications, analysis, and or files. To break that down a little further, we have a Docker image, which is a single file that contains everything you need to run an application. This includes a cut down version of an operating system, environment runtime, like Node or Python, libraries, and environment variables. A Docker file is what defines the configuration for the Docker image. That is, a Docker file will define the base image, including the operating system. It defines the application's dependencies, configuration, and environment variables, which will all be put together and built into an image. We're going to discuss Docker files a little bit more later in this workshop, and we will ask you to build your own. But for now, it's worth noting that Dockerfile is both the file type and the file name of the configuration file. So Docker will look for a file named specifically Dockerfile to build the image. So using the Dockerfile, we build an image. And building the image is a process which downloads, configures, and wraps together all the components into the single file, which we call an image. All right. Okay, so as we just mentioned, the Docker image is a static file. However, it's not a running environment. We call the running execution environment built from a Docker image a container. These terms are sometimes used interchangeably, which can be very confusing, but we want to highlight the difference here. So just to reiterate, a Docker image is like a blueprint or a template containing all the necessary instructions and files to create a running application environment. Essentially, it's a snapshot of a specific state. A Docker container is a live running instance of that image, allowing you to actually execute the application by creating an isolated environment based on the image's specifications. In a simple analogy, an image is like a recipe, and a container is like the cooked dish made from that recipe. We'll explore how this works in some exercises soon, but a couple things to note here. The container has a separate file system and a separate set of applications and configurations that are sectioned off from the rest of your computer. So what you do in a running container will not affect the rest of your computer that it's running on, right? So if you spin up a container and you download a version of Python, that version of Python is not on your machine. It's only on the container. The exception here is mounted directories, and we're going to look at that a little closer later to help you understand how that works. Another note is that you can run multiple containers at the same time from the same image on the same machine, or you can have multiple containers from multiple images running on your computer. So, to return to the food analogy, you could imagine that you could create multiple batches of the same dish from the same recipe or cook different dishes from different recipes at any given time. The same thing applies here. You can run multiple images simultaneously. All right, so in addition to Docker files, Docker images, and Docker containers, we also have container registries. So container registry is a place where Docker images are held and can be uploaded and downloaded to share across users and locations. So this diagram is showing that you can build an image, and then there's this dotted line along the bottom showing that you can go straight to a container. You can run a container right from that image on your local machine. But there's this other path that we can follow along where you would build the image locally and then push it up to a registry. In this case, today we're going to be using Docker Hub. And then that image can be pulled either back to your local machine or another location, say another user or a cloud, a cloud running environment, a VM on a cloud, for instance. And then it can be run to create a container. So this is how we use it with WDL and cloud native applications, right? We push things up to the Docker Hub registry, and then it can be pulled down and used in that other environment or by another user. All right. Okay, so just to recap the basics here, we have an image, which is packaged code and its dependencies. This is portable software. It runs quickly and reliably is the goal. A container is the running instance of the image. It's packaged up, isolated software environment, and all dependencies are included. A registry is a cloud repository to store images privately or publicly. There's a couple different registries that are commonly used. Here are some of the common ones. There are others available, but Docker Hub is kind of the native one for Docker. There's also Key, Quay, or K, depending on your pronunciation preference. .io that is commonly used, and then Google Artifact Registry is another one our team uses often. Another concept that we wanted to mention here are official images. So I can follow this link here. If you click this link here, this is going to take you to a page that describes what official images are, but perhaps more useful is actually going to the images themselves. So these images are official images blessed by Docker. So they've been scanned for security vulnerabilities and they're maintained and kept up to date. These are a really good choice to use for base images. So you can see there's like a Python official image. So if you were running something that needed Python, this could be a really, really useful base image for you to build from. And we'll talk a little bit more about base images when we get to the Dockerfile section. But Ubuntu, Python, like these are common base images that you may want to use. So it's just good to know that there are official images there. Another note that container and image are often used interchangeably, but we already went over what the distinction is there. Cool. So how do we use Docker images? So one way we can use Docker images is interactively with the Docker CLI or command line interface. Docker CLI is a command line utility. It allows us to download and build Docker images, also run Docker containers, and then manage the Docker images, containers, etc. on our machine. You can think about needing to be able to clean things up after you've used it and allow for getting disk space back. We also can use Docker images in WDL. So this is, I believe, the subject of tomorrow, writing WDL, but today we'll note that you would specify what Docker container you need to use for each command when you write a WDL workflow. And so the way that you specify this is just Docker, and then the path to where that Docker will be pulled from, so the registry that it will be pulled from. And that allows you to contain the environment that the code will run in and ensure that it's running the same way every time. All right. Okay, so we will now get to a real example. And this example is going to be analyzing sequencing data. In this case, we're going to take a look at a BAM file. So as you think about writing a workflow in WDL, as I mentioned, we'll need to specify the Docker for each task. Here we recommend that you pare down the Docker image that you use and try to isolate the software that you need only for, the task that is being used. That is, you could imagine that you could cram everything into a single image, right? If you have a large workflow and it needs 10 different bioinformatics tools, you could cram those all into one image and have one mega image that does everything. That is not generally our recommended best practice. And so what we would say is if you have 10 different steps in your WDL and each one needs one bioinformatics tool, you would likely make one Docker image per bioinformatics tool. That's just one of the ways we recommend doing it. So here we're going to look at a Docker that has SAM tools installed on it, and I believe probably some Python as well. But here we're going to use SAM tools. So what we're going to do is we're going to use a BAM file. The input is a BAM or aligned sequence reads. And then we're going to use SAM tools index to index the BAM. And then we're going to use SAM tools IDX stats to calculate some quality metrics. And then finally, the quality metrics will be output, right? So it creates a text file containing the quality metrics. So this is the example we're going to walk through together. And we have a Docker image for you to pull already made for this. So we'll look at that a little bit too. All right, so this is our first exercise. As I mentioned at the top of this with logistics, what we're going to do is I'll describe the exercise first, and then you'll get a chance to try it out. So I'll walk through each of these steps, and I can actually demo them live as well, and then you can go and do it yourself as well. So in this simple example, we're going to pull a Docker image and then run a Docker container that we've set up with SAM tools. Before starting, you'll need to make sure that Docker Desktop is running on your computer. So do I have Docker Desktop running? It was running yesterday. You know what? Let's run it and we'll find out. Let's go back, see if I can. Oh, it's not going to let me highlight. Interesting. Okay. All right. So I may have to exit presenter mode. Let's see. Escape. Yes, and now you can all see my notes. Let's go back to presenter mode and see if it'll let me highlight. It will not. Okay, sorry.
Would it be helpful
Apologies.
for us to stick it in the chat for you? Or
Yeah, I mean, I can also type it. It's just
I'll put it in the
slightly harder.
chat, and that
Thank
way
you.
other people can grab it too, hopefully easily. I don't know. Sometimes it doesn't let you copy from chat.
All right, cool. I think this will also demo that my Docker is not running, which could be useful. V1. Yes. Okay. So if you do not have Docker running, this is the warning you'll see, and then you can go ahead and start Docker running. So I'm just going to go open my Docker desktop, and it may make me sign in. It did not make me sign in. So now we can try again. And you'll see I did actually already have this, but there it is. It went ahead and downloaded that. Okay. And then the next thing you'll do is run the image. So if we walk through this command, let me just get that out of the way for you. You're gonna, let's see, pull it, and then we're gonna run it. So this Docker run command, part 2 here has this IT flag right here. And so that is telling Docker to run this in interactive mode, which will allow you to interact with the running container. And bash at the end here is supplying the entry point. So this will give us a command line prompt in our running container. So if we try that out, thank you, Liz, for posting that in the chat as well. we'll see that I get a warning. This is another good thing to point out here, is that if you're running this on a Mac that's newer than 2021, you are going to see this warning. You can safely ignore this warning. It's just saying that the image was built for a platform that is different than the platform I'm running it on. And it's not a problem. It's totally fine for our purposes today. And we have some tips later on how to avoid that warning when you're building an image. But for now, safe to ignore. Once you have this, you can see I am now in my running container and I can look around. I can print working directory. I can list what's here. I will leave the calling of SAM tools for you to try out, but when I am all done, I can type exit and it exits the container and I'm back to my command line prompt. So that's what we're going to have you do. We'll have you run the container and then check things out, look around a little bit, run some common commands. And then we're going to ask that you run SAM tools to see if SAM tools is installed. You should see the help for SAM tools pop up when you run that. And then finally, check for this test data folder and see if there is anything in this called test data. So you can look around and see if that's there. It would be in the root. There's a hint here of what the answer to that question should be. And then when you're all done, go ahead and hit exit and raise your hand. If you decide not to do this, if you could just raise your hand, we would really appreciate it so that we're not waiting on you to move on. If you have any questions or issues come up, feel free to come off mute and ask questions or hop in the chat and post your question there, and we'll be ready to help. So I'll leave these instructions up, but feel free to take a few minutes to do that.
We still have a few folks, it looks like, who are trying the example. So we can give another minute. Jess, there was a question in the chat. Maybe you can answer. Where is Docker actually putting the disk image on your computer when you download it, when you do the pull command? Do you know?
I don't know the answer to that off the top of my head. Is something we could probably figure out. What I do know is you could run Docker image list to find a list of images on your computer. So if you're interested in seeing what's there, um, that's one way you can find that. And towards the end of this, we have those commands written out that you can look at to explore those types of things. Yeah, so that would tell you what's on your machine, but where exactly they're being stored, I'm not sure of the answer to that. No, Docker Desktop is not required to run Docker. There are other ways that you can do it. Docker Desktop is super convenient, but yes, if you're at Broad and you don't want to pay for it, Bits is recommending using Podman. I have heard from others that that is not as seamless as one would hope. I have not personally tried it myself, but that is one alternative. There are other ways that you can interact with it. Somebody put together a how to set up, I don't remember what the particular software was, but there's another software that does something similar, and a tutorial of how to set that up. And it was non-trivial to make the switch, which is why we didn't include it here as the recommended way to do things. But if anybody's interested in seeing a tutorial of how to set up something free, I'm happy to get the person to link it, and we can send that to you. So reach out and we can send that along.
Okay. There are a few more people who haven't put their hand up yet. Would anyone like more time? Maybe unmute, let us know. Okay, I think then people can put their hands down and lower hands and back to Jess.
All right, thanks, Liz. Okay, cool. So if you followed along, you should see that there is no test data folder. There's a pretty big spoiler hint on that slide, but yes, there should be no test data folder at this time. But if we need to get our data into our running container in order to interact with it. So how do we do that? So the next exercise is going to talk about that. We've pulled the image, we've run the image, but now we need to make our data available to interact with the software. So we're going to mount a directory from our local computer into our running Docker container. Again, I'll go ahead and walk through the steps here, and then we will give you time to do it yourself. So the first thing you're going to do is you're going to make a SAM tools test directory on your local computer. You'll use this command here, make dir SAM tools test. To do that, you can see that I already have SAM tools test. I've maybe done this before. So I already have my directory, but you can go ahead and use that command to make a directory. Then you're going to download the Neurons 2K mouse BAM into the new directory, which Liz has been so kind as to post a link to that in the chat as well. And as you can see, I have already done that as well. I actually, spoiler, already have the outputs here too. I should have removed those. Apologies. Okay, so then the next thing we're going to do is mount the local data folder to the new Docker container and run the container using these commands. So we have a Mac version and a Windows version. I do want to point out here, and I will run this command momentarily so that you can see how it's done on my computer, but this is not a copy paste. It's close, but it's not quite. So here you're going to have to change the path to SAM tools test to be the path to where it is on your machine, and it needs to be an absolute path. So we're going to change that. But basically what this command is going to do, it's Docker run, which is going to create a running container. Again, we have this IT flag here, which is going to put it in interactive mode. But the new part here is this -v with the path. So this -v is telling Docker to mount a volume to your container. In this case, you're going to mount the location of the SAM tools test directory, and you're going to mount it to a location called test data in your container. Again, bash is our entry point, giving us that command line prompt that allows us to interact with the container. So I'll go ahead and run this now. Docker run -v. And then actually, you know what? I'm going to print my working directory because I'm lazy first. And so that tells me exactly where it is. Now I can do this. -v, and then I can just copy and paste this. And is there a trailing slash? Yeah, no, we don't want a trailing slash. Okay. But we do want a leading slash for test
We do
data.
you oh, it does have a trailing slash on it. Whether that's meant to be or not.
Okay, not
On
on our
the
Mac example, but I
Oh,
think
I
it
see.
should be fine either way. Let's try it with the trailing slash. Sorry. And then we want to run dash dash or dash IT and the name of our image here. I'm sorry, I can't see it. E Kiernan slash Docker 101. And V1 is the tag for that particular version of the image and bash. Okay, and then we just hit run. And it gives me the same warning. Again, not a problem. But now we can see if we ls, there should be this test data folder. Okay, so returning back to our instructions, we've got that running. Okay, so then in Docker, you're going to use SAM tools to index the BAM file. And you can use this command exactly as shown here. And then also in the Docker, you're going to use SAM tools IDX stats to QC the BAM file and write it to the test data folder. So again, you can use this command exactly as written here, which Liz has so kindly put in the chat. And then exit when you're done and raise your hand. And I think we probably don't need to watch me paste those in, but you can see how it would be done. The main thing to keep in mind here is that you're going to have to update this path too. Otherwise, you can use the commands as listed here. All right, so we'll take a few minutes to do that and raise your hand when you have completed this, or if you are not participating, then please also raise your hand. So I see a question in the chat of where to find the output file in your local directory. We will look at that in a minute after people have completed, but just to give you a quick preview, it will be in that SAM tools test directory that you just created and mounted.
I haven't seen any new hands go up for a couple minutes here. I just want to make sure no one is stuck anywhere. Oh, there's a new hand.
Okay, I see a question about a BAM file not being present in the test data folder. So um, if you don't use the full path to the SAM tools test directory where the BAM file is, that could be one reason why. Um, if it wasn't in this SAM tools test directory, that could be another reason why. I don't know if either of those might apply. And yeah, just to note that the test data is what we're calling it within the container, but on your local machine, it'll be called SAM tools test is the directory name.
Yeah. Yeah. So you will have to actually download the Neurons 2K BAM to that SAM tools test directory to start, and then make sure you mount it to that test data folder in the container. And that test data folder gets created then when you do this Docker run command. We have another question about how to check the test data file in my local file. Um, so that you want to take that, Jess?
Yeah, so that is one of the things that this exercise is meant to highlight is that when you mount a directory into a running container, in this case, we've mounted SAM tools test into the running container as test data. Whatever we do in the test data directory will be reflected in your local directory. In this case, that's called SAM tools test. So if we create files, delete files, edit files in that test data directory within our running Docker container, we will see those changes reflected in the SAM tools test directory. Here we're actually creating two new files, the index file and then the QC file. And those should be accessible in the SAM tools test directory on your local machine after you've done these changes in your running Docker container. Did that answer your question? Hopefully.
You're going to show that too, right? Is that what you said? You're
Yeah,
gonna.
I can show that when we're ready to move on. Let me just go clean up mine so that we can see that live. Right, it looks like most hands are raised. Does anybody want another minute? Taking the thumbs up is maybe another minute or so. Okay. I'll go ahead and demonstrate what we expect to see, and then we can probably, if anybody needs another minute to finish up, can do that while I'm talking through this. Um, so you can go ahead and lower your hands, but we'll just recap. So what we saw is that in our SAM tools local directory, we have the mouse BAM file here. And then if we go ahead and run mounting this particular directory to our Docker, it gives us a running container where we can see our test data is there. If we then run the SAM tools command, um, it will run pretty quickly, I hope. Yep. Um, I guess I should have shown that in the test data. We now have both the BAM and the BAM index file. And then if I go ahead and run the next command, that will output into this stats.txt file. And we can see that now there's this stats.txt file here as well. This is inside our container running um, in our test data folder, which is mounted from our SAM tools test folder. So as you can see up here in our SAM tools test folder, we only had the BAM. Now if I go ahead and exit and we check this folder again, we now have the BAM file as well as the BAM index file we just created inside our container and the stats file that we just created inside our container. And that's back in the SAM tools test folder on my local machine. So you can see that when you change something in a mounted directory, it will change in your local environment as well. So that's what we were trying to demonstrate here. Hopefully you guys were all able to see that on your end as well. All right. So this is showing what you should see. The output is a tabbed limited file with each line consisting of several different things. And this is the output for that stats.txt file. So that's what we were expecting to get from this exercise. And you should see that it was available on your local directory as well as in the running container. All right. So the next thing we're going to look at is building an image with a Docker file. So we talked earlier about Docker files being the way that we can specify what goes into our image. So we specify all the different components that we need to put into our image in order to have our container running with the software and all its dependencies that it needs to run. So we're going to talk a little bit here about what the different parts of a Docker file are, and then we'll look at building an image from a Docker file as well. So Dockerfile is a simple text file with instructions to build an image. It's written in YAML syntax. If you're not familiar with that, it's indent specified, so you can. It's relatively human readable and uses indents to break up logical blocks. So what we start with is this from command. Each Docker file will start with a from command and you specify a base image there. And so we'll get to some best practices later, but our team recommends starting with a smaller base image where possible. But you're going to specify what image you're going to build on top of. And then you can add some metadata. Here we have a maintainer. You might have some labels or something else like that you would use as metadata. And then the run command is where you're going to install software and dependencies. So that will be, whatever you need to install to get your application running. And then you can also bring in scripts. We don't have a copy command here, but we'll see an example of that in some example Docker files. You can use env to specify environment variables. And finally, the last thing we want to point out here is the cmd command, which is the command that runs when the container starts. So you can think of the run this run anything in the run section is going to run when you build the image. Anything in the CMD section is going to run when you run the image. So when you create a container, and that's optional. It's not required. Okay, so we'll take a look at a couple examples of some Docker files. So the one we were just using, the SAM tools Docker that we were just running, this is the Docker file that built that image. So you can see the from Conda Forge, Mamba Forge, this is the base image that we used. And then here's the run command, which configured Conda, added some things, and then installed SAM tools into that image. And that's so it can be very simple like this. It can also get a little bit more complicated. So here's some real examples from Warp, which is Whittle Analysis Research Pipelines. That is the repository that the DSP pipeline development team maintains of Whittle pipelines. And so here's an example. This one in particular is BWA, so the alignment tool, BWA. And you can see it's a little bit more complicated than the last one. So we've got the from, again, this platform is what you would add to avoid that warning that we saw. And Ubuntu is the base image. Here, the tag is specifying a specific version. If you don't put a tag, you would get latest. And that's fine if you're fine with it. If you want to pin a tag, that would keep it consistent through every build. Then we have some arguments, the environment variables, a label. This is just some metadata. Working directory allows you to switch where you're running the run commands. Here's some run commands to install stuff. And finally, an entry point. We've got one more to look through. Again, we've got some metadata here. The from is specifying the base image. There's several run commands, and we can talk a little bit more about that in best practices. But the one that might be of interest here is copy, which can be used to copy in files from the local environment where it's building. So here we're copying files from the Warp Tools directory. Cool. So that's just some examples. All right, so the next exercise is going to be preparing your Docker Hub repository. So ideally, you would have already signed up for a Docker Hub account. If you haven't done that, you can do that now. But you're going to go ahead and log into your Docker Hub account or create one if you haven't already. In Docker Hub, we're going to create a repository, and I'll walk through this in just a second, so you can see what we're asking you to do and then go do it yourself. You're going to add a name for your repository, make it visible to public, and then we say create and then create. There's a button to finalize it that you will click. That's what this is referring to. And then go ahead and log in from your terminal if needed. So I will go ahead and show you what this is going to look like. So here we have Docker Hub, and I'm going to sign in. Hopefully with Google. Continue. Okay. So this is the create a repository link. And I guess that's what it took me to. Okay. So now we can name our repository. Let's name it Docker 101, right? This is what we want to do. Yeah. Create a repository. Docker 101 is what we're going to call ours. And you can put a description if you want. You need to make sure it's set to public. What else? And then we just go ahead and create it. So we'll do that. Oops, I already have that. Docker 101 example. Okay. Has to be unique to you. All right, so now you can see I have this repository all set. And then you can do Docker login from your terminal, just like this, if needed. and my login has succeeded. So this is all we're asking you to do here. Once you've done these steps, if you could go ahead and raise your hand or pop into the chat with any questions or come off mute is fine too. Um, let us know if there's any troubles. Cool. Seeing most hands up. Does anyone need another minute? Okay. We'll go ahead and proceed. Do feel free to reach out if you've had any issues with this. All right, so the next exercise is going to be downloading, building, and pushing your Docker image. So for this, we're going to have you download this example Docker file, and we'll drop a link in the chat. Thank you, TAs, for doing that. Into a new folder on your local machine. So you can make a folder and call it My Project, for instance. Um, and I can walk us through this. Let's go ahead and walk us through this. So we will just make a new folder. In my temp. Okay, so we're going to make a folder called my project, sorry. Okay, and then we're going to go into that, my project, and then we can download the example Docker file here. Download that. Okay. And then from here, we can bring that into this particular folder. Bring it here. Okay, so now I have my Docker file here. And if we want to see what that Docker file looks like, we can take a quick look at it. You can see it's the one that we just used. So great. Okay, so now you should have, well, when you do this, you will have your example Docker file in your folder, and then open a terminal window and navigate to the folder. I did that from my terminal. You don't have to. You can move it there another way. Then you're going to run the command docker build -t, and then you're going to use your Docker Hub account name, your repo name, and your tag to build it. So as an example, Liz is the one that put this together originally. Her Docker Hub account name is E. Kiernan, and the Docker 101 version 1 is the repo name and the tag name that we've been pulling. So this is the command Liz would have run to build that image that we've all been pulling. I can show what this is going to look like on mine. So if we look here, my Docker name is Jessica Way. My Docker Hub repository is Docker 101 example. So I can use this to build my image, and it's going to look like this: Docker build -t, those things I just copied, and a tag, and the period to specify that we're building the Docker file here in this folder. Okay, so Docker build -t, my name and repository, a colon, a tag, and we want to build it here. So you can see my command looks similar, but it's a little bit different. I did have to change it. And then we can build that. And you'll see it will do some things to download and build and resolve things. If you're running on Mac 2021 or later, you can include, I didn't, as you see, and it will run fine. But you can include Docker build -- platform Linux AMD 64 before your -t. So you see the -t is still the same -t. So you can just pop this part right in here, and that will tell it what the target platform is so that it avoids these warnings that we've been getting. Finally, we're going to push our newly built Docker image up to our repository. So you can see here, we're going to have to change this again to the Docker Hub account name, repo, and tag. And here's an example of what that looked like for Liz. And I can show you an example of what that will look like for me after this builds, maybe. Building 5 of 6. Okay, so might take a minute. Um, it's going to look similar. Maybe I'll have you guys get started on this. And if anyone runs into trouble, I can demo this part too. Um, so go ahead and start running these commands and raise your hand when you're done, or reach out if you run into any issues.
We had an interesting question in the chat about what happens if you use a different name instead of Dockerfile. Um, Happy to answer that one, or I can turn it to you, Jess.
No, please go ahead, Liz.
So Dockerfile is the default name. And I believe that if you can use a different name than Dockerfile, but you're going to have to specify it then with certain flags in your Docker command. So, and I'm not sure what those are off the top of my head, but yeah, it does by default assume Dockerfile without an extension.
I believe the final part of this command also specifies where that Docker file should be found. And so since you're running this command in the directory that contains the Docker file you want to build, you just use the period character to specify here. But you could theoretically build in a different directory as well. Seeing most hands raised. Does anyone need another minute? Okay. So mine did finish building and I was able to push it. So what we should see now is we should see a new tag in our repository. Yep, here's version 1 that I just pushed 3 minutes ago. So you should be able to see that in your Docker Hub account where you pushed as well. Okay. So the next exercise here is just managing images on your computer. Well, managing Dockers, right? Docker images, Docker containers, etc. And so these, we won't necessarily have you run all of these commands, but these are some commands that may be useful for managing things on your computer. One trick that I like to use personally, if I'm just going to spin something up real quick to do something, is this dash dash RM parameter. So when you add this to a Docker run command, it will remove the container after exiting. Um, and so that means it's not like hanging around, continuing to exist. When you hit exit, the container is gone. It just gets removed. So that's handy if you just want to spin something up and do something quick, but you don't need it to persist. If you want to check the containers on your computer, you can run this docker ps-a. I'm sure my stuff is a mess, but you can also run docker image ls if you want to see all the images you have, and that's sort of what it would look like. It says the name of it, the tag, creation date, approximately. So you can use that to see what's running. Removing all images and containers, Docker system prune -a, and then remove volumes, Docker system prune volume A. If you don't want to remove all, there's variations of these commands that will be available if you look through the Docker documentation. So that's a recommended thing to do. But we just wanted to call out that some of these things are available to help you manage things on your computer. All right, we've got a section here on Warp Docker best practices. I'm not going to read through all of this. It's mostly provided as a resource for you to look at if you are writing Dockers, but we'll look briefly through some of this. So we do have a link out to a best practices document with a style guide. Feel free to check this out if you're so inclined. But you can see that there's quite a bit of information here for you to read through. I'm certainly not going to read this to you now. Some of the things to note from that are we recommend reducing image size. So I mentioned earlier that this can look like using a small base image, something like Alpine. Alpine in particular can be a little bit difficult to work with because it is so pared down. It has very minimal things, but it is also very small. So if you can make it work, it has the advantage of being very small. Also, that can also look like minimizing the amount of different applications you add to a single image, right? So we needed SAM tools for our example, and we only put SAM tools in there. We didn't need to add card as well and GATK because we weren't using those. And so if you think about just using the image for one contained piece of analysis, and then using a different image for a different piece of analysis that uses different software. That's another way to keep things small. We also have recommended minimal run steps. There is a caveat here in that each run step that you add adds a layer that will cache. And so there can be reasons to break things into multiple run steps. If you have a very, very long running run step and you have one downstream that's giving you trouble, it can be very handy to separate those out so that you're not having something download and install for an hour and then this next command fails and you're troubleshooting it, right? Like if you separate that out, that hour-long install will cache, and then you can move on to the next part that's giving you trouble and you're needing to iterate on. So there can be reasons to separate out run steps, but generally keeping them minimal is a good idea. All right. Other best practices, making Dockers publicly accessible. So you can do that by using one of these public repositories and setting it to public, viewable, and then using semantic versioning. So more on that on the README there that I pointed you to, but basically we want things to be human readable and to be able to tell what's an older version and what's a newer version. Some more best practices. I'm not going to run through these. I will leave these to you to read through as you feel the need to. But there's a bunch of things to think about here if you're so inclined to look at them. All right. We also have some next steps. There's a homework scenario to follow along if you're interested in looking more into this. And there's some Dockers that you can use to test that out. Um, and some steps that you can follow along here. We are not going to keep these as exercises to do live right now, but those are there if you are interested in doing more with this and want like a little bit more tutorial to walk through. Finally, we have some resources here. The Dockerfile reference from Docker. This is actually super handy. It walks you through what the different parts of a Docker file are and how you can use them. So we talked about some of these. The from is your base image, and a bunch of other things that you can use here, but that's a handy guide. There's a tutorial from Docker on how to get started. Here's some official images. We talked a little bit about those too, but these are some handy ones. Our base image, Python, Ubuntu for just simple bash type commands that you need to do. And then our best practices that we already looked at. Um, Here is a link to the survey. We'll drop that in the chat as well. If you're willing to provide feedback, it should take 5 minutes or less. We would really appreciate that feedback. It's super helpful to us. Thank you for dropping that link in the chat. And then some upcoming workshops. Tomorrow is Introduction to WDL, and Thursday we have GitHub Doc Store integration. So we encourage you to attend those if you're interested in those topics. And a contact for us. I'll put the survey link back up. But if anyone has questions and wants to come off mute or has anything else, we'll stay for a few minutes. That is the main content. Thank you so much for participating today.
Jess, we did have a question
Yeah.
that might be fun to discuss. It kind of goes nicely into tomorrow's topic, where people are going to learn how to use the Docker actually in a WDL that they built today. But the question was from Chris, and he asked, if we are running multiple workflows, let's say two different variant calling tools, and then aggregate their output, should we have two different images for each?
Yeah. So it's a good question. It's I think the short answer is it depends, which is not super helpful. But it depends, right? It depends on what you're looking at. So one school of thought that we have as the pipeline team is that like you want to make everything as modular as possible and as like logically broken up as possible. And so my first answer would be like, yeah, let's go ahead and split those into two different tasks and run two different images with the different software. But that isn't always extremely practical. So this gets into the like topic of optimization and how you optimize a workflow. And so I think it's a case by case basis, and our answer would be to do what makes sense. In some cases, if you're needing to load the same files into both tasks, and do similar steps on the same files. And let's say you have tons and tons of files, or these are huge files. And so it takes a long time to load all these files into the VMs. And then you're doing a quick operation on them. And then it's a long time to delocalize them again. Now we start to get to where it might make sense for you to combine these, right? And it might make sense for you to do the two different variant calling tasks or steps in the same task. And so you would load all your files in once, run one step, run another step, maybe even aggregate them at the same time, depending on what your workflow looks like, and then output the output there. So it really sort of depends on what the shape of your workflow looks like. I would say best practice is to use your judgment. I'm sure that's not super helpful. Um, yeah, as a default, I would say like think about breaking things into logical chunks and then work back from there to see what makes sense for your particular workflow. That being said, as far as like optimizing time and cost of a workflow, we actually do find the fewer steps that you have, the more optimal it is. And so it can be useful to minimize the steps that you're doing and combine things into a single image when it makes sense to do that. Is that helpful, Chris?
Yeah, this is very helpful. Thank you. I think the one thing I wanted to maybe clarify is in a situation where, I'm building the workflow, but like let's say I found in the literature group A published this tool, group B published this tool, and I'm like, well, they're both good. I want to leverage the strength of both tools into one workflow. Then in this case, they each have their own, let's say, Docker image for their own tool. But would that mean like in my Docker image, I would just be calling each of them like it doesn't make sense. Like I have my own Docker image for my own workflow, but I'm calling each of those tools to their own Docker image.
Um, oh, like your image would use those images?
Exactly. Yeah, exactly. I don't
Okay.
know how that would work.
So I'm not sure if that's possible. I think generally you'll think about it as like one Docker image creates one compute environment where your commands are executed. What you could do is if you wanted to combine the tools into a single image, you could start with one of their images as your base image and then layer the other software on top of it, right? So you can say, like, for instance, if you have GATK, you can use the GATK published image as your base image and then layer in another variant calling tool on top of that to create your image that would have both softwares, where you could then, in your compute environment, call each software separately, if that makes sense.
Yeah, that makes sense. Thank you.
Okay. Yeah, and whether you would want to do that, right, and do it all in one step, or you would want to separate it out and then bring the outputs together in a third step, um, probably just depends on the shape of your workflow, but both are options. Can you pipe input output from a running Docker image into another image? So from one container into another container? Um, oh, okay. So I think the answer to that, and if anybody else has ideas about this, please jump in. I think the answer to that is sort of, and it depends on where you're running. So if you're doing this from a WDL and you're running with Cromwell and Terra, no. Um, you what would happen is from that, like that is what the WDL's doing for you, right? Is that you take one VM that you spin up, which is running one Docker image, and then the output of that is then put into the next task, and that's what the WDL is managing for you. That is the what the purpose of the workflow is, right? So it takes the output from one task and puts it as the input to the next task. Um, and so it's sort of doing that pipe for you. But as far as like it actually piping directly, no, that's not exactly how it happens. It is happening that it gets copied into one VM. Whatever transformation you're doing happens in that VM. It's copied back out of that VM, and then it's copied back into the new VM, where it's operated on again. If you are operating on your local machine, you could do this in a hacky way by mounting the same disk to both, right? So you could mount the same directory to both, and then that would make that directory available in both running containers. I don't recommend this. It just seems like a headache that's going to get messy. But I think it's theoretically possible. Any other questions or things we can help with?
All right. Well, it sounds like there are no more questions for today, and we've gotten to the end of the day's agenda. So thanks again, everyone, for joining us. Join us again tomorrow when we'll go over how to actually write whittles. It's going to be a very fun demo. So we're looking forward to seeing everyone again tomorrow. And if you haven't had a chance to fill out the survey, please do. Let us know how you felt about the content and the pacing of the day's presentation. So thanks, everyone. We'll see you tomorrow.
Thanks.
Thank you.
Chris, I see you have questions about yesterday.
Yes, thank you, Anton. So yesterday I was not able to get the cost object for when I try to copy the workspace on Terra for the actual. I don't know if I know I was added or I don't know. Yeah.
Um, can you give me your email address? Would you mind just typing it into the
Yeah.
chat? I'll make sure you're added. Hold on just 1 second. Okay, you should be good to go.
Okay. We'll see if I try to clone it now. Okay, but yeah, I see it. So the bootcamp March 2025.
Yes.
Okay, awesome. Thank you so much. Yeah.
Yes, of course. We'll see you tomorrow then.
I'll see you tomorrow. Bye.
Bye bye.